Alright, so let me demonstrate how to solve this question. So we have to integrate root x cube plus 1 with respect to x first, okay, from this limit to that limit, and then whatever there is a result, we have to integrate with respect to y from 0 to 1. So with a little bit of struggle, you would realize that integrating in this order will be next to impossible, because there is no antiderivative for square root of x cube plus 1. Okay, so what you want to do is try doing in the reverse order. Okay, so to get the order, what do you want to do? You have to sketch the domain. Okay, so for that we need to sketch the domain. Okay, so what we have is y is going from 0 to 1 and x is going from root y to 1. Okay, so let's have the axis here. This is xy. Okay, and you have this one is the curve is x is equal to root y. Okay, so x is equal to root y, the same as y is equal to x square. Okay, so we have this particular curve. Okay, I'm only drawing the right branch because it is the positive square root. Okay, so this is x is equal to root y, or same as y is equal to x square. Okay, so this one is saying y was going from 0 to 1. Okay, y was going from 0 to 1, 0 to 1. Okay, and for each of those y, x was going from root y to 1. Okay, so seems like there is a line x is equal to 1. Okay, and seems like our region of interest is this one. Right, y was going from 0 to 1. Okay, and for each of those y, x was going from this curve to the curve x is equal to 1. Okay, so then once you have that, you can easily write the integration in the reverse order. In reverse order, will look like what? So outside is x dx, and then you want to go dx, and so in this region x is going from 0 to 1. Okay, and for each of the x in between, y goes from 0 to this particular curve, y is equal to x square. Okay, so you have that dy, y goes from 0 to x square. Okay, then what you have integrating. Okay, and this is doable because once we are doing this, then the inner integration is a function of x, but we are integrating with respect to y. So root x cube plus 1 is just a constant with respect to y. So this is same as this case can be rewritten as 0 to 1 x cube plus 1, 0 to 1 0 to x square dy and whole thing integrated with respect to x. Okay, and these are easily doable. So the inner integration becomes 0 to 1 x cube plus 1, and this becomes x square right, and then from here you can complete it by u substitution. Okay, so I'm not going to do that. So main trick is to observe that, realize that you need to try it in the convert the integration from dx dy to dy dx. Okay, and that lets you bring in an extra factor which is helpful in u substitution. Okay, that's all.